In the previous module, we looked at the three main maintenance strategies in use today: reactive, preventive, and predictive maintenance. Over the next two modules, we will look more closely at the predictive maintenance strategy and what it means for users of low and medium voltage motors and generators. The predictive maintenance strategy uses the actual condition of the equipment to plan what maintenance needs to be performed and when it should be carried out. Various machine components are monitored by different on- and offline measurements. As these measurements are used to assess the condition of the motor, the process is called condition monitoring. In an earlier module, we looked at the different factors that can affect a motor's performance, leading to a maintenance requirement. Many of those can be measured as part of a condition monitoring program, but the most common ones concern the power, vibrations, and temperature. Readings can be taken online while the machine is running and offline during a scheduled maintenance break. Deciding what needs to be measured and whether the readings are taken on or offline is highly dependent on the size and power of the motor being monitored, and it is here that the differences between low and high-powered motors become more apparent. With lower power motors, the failures tend to be due to issues with the bearings, whereas with high-power motors, the problems tend to lie more in the stator windings and rotor bars, the parts of the motor under the most stress, both electrical and mechanical. The condition of these internal active parts usually require direct inspection and measurement, so inspections are performed offline, in addition to the online measurements taken while the machine is running. We'll take a deeper look into the on- and offline measurements used for condition monitoring high-power motors in the next module. In contrast, the windings in low-power, low-voltage motors are under less electromechanical stress and rarely need internal inspection. This means that the condition can usually be adequately assessed using online monitoring only. To simplify online condition monitoring of low-voltage motors, ABB provides an all-in-one solution called ABB Ability Smart Sensor for motors. Attached to the side of the motor, the sensor unit monitors signals from the motor and transfers the data to a secure server in the cloud. The server then analyzes the data to produce diagnostic information and performance alerts that can be sent directly to the user's smart device. A simple traffic light display gives a quick overview of the motor's condition, allowing necessary maintenance to be planned and executed before the motor's condition worsens and causes an unplanned production stop. Knowing this information allows maintenance resources to be deployed more efficiently, which in turn improves performance and extends the lifetime of the motor. By minimizing outages caused by failed motors, plant productivity and profitability can also increase. In the next module, we will look at the on- and offline measurements used in condition monitoring for high-powered motors.